Alright class, this video follows the other one where we were doing complex numbers synthetically dividing by like 2 i's and stuff. This is a more complex problem. This time I'm going to give you a complex 0 that is like 2 plus or something plus bi. So today we're going to do, given that 2 plus 3i is a 0 of this polynomial. Now note this, if you have a typed note sheet, it should say a 1 here. If it doesn't, please change it to a 3x to the 4th minus x cubed minus 9x squared plus 159x minus 52. Find the remaining zeros. Well, first of all, we know the first remaining 0 is the complex conjugate of 2 plus 3i. So we know another answer has to be 2 minus 3i. Okay? Now all you do is you do what we did before. You synthetically divide by 2 plus 3i. When you do this, you want to leave some space because it's going to get a little bit bigger. So we have 3, negative 1, negative 9, 159, negative 52. Okay? So the first thing you do is bring the 3 down, like normal, and then multiply it to the 0. So 3 times 2 is 6, plus 3 times 3 is 9i. Then when you add down, you only add the real parts. So 6 goes with the negative 1, so we have a 5. Here's where it gets messy, and here's where we're going to make it easier on ourselves. We now have to multiply this times this, which looks like this if you do it. The problem with doing that is we're going to have to FOIL and simplify. Then we're going to have to do it again and again, which can be a lot of work for one problem. So for you guys, we're allowing you to use your calculator for something like this. So when you need to multiply two things, 5 plus 9i, 2 plus 3i, let's go to the calculator and you do parentheses 5 plus 9, and then to get an I, it's second decimal point. Alright, and then it's 2 plus 3i, so it's 2 plus 3 and then second decimal point. And when you type that in like that, you hit enter, it FOILs it for you. And it simplifies it for you, and you get a negative 17 plus 33i. So I get negative 17 plus 33i. You add these two numbers together because they're the ones that are like, so we get negative 26 plus 33i. Okay? Now we FOIL it again. We do this one now times the 2 plus 3i. So negative 26 plus 33 second dot times 2 plus 3i. And we hit enter. We get negative 151 minus 12i. Negative 151 minus 12i. When you add those together, you get an 8 minus 12i. And then we can do 8 minus 12i with the 2 plus 3i. So again, 8 minus 12 second decimal point. And then 2 plus 3, hopefully this gives us a negative 52. Good, it does. So we get 52, which is what we want because that's a negative 52 and we get 0. Okay. So that doesn't help. I mean, it helped us. We divided it once, but we need to divide again for it to keep going because right now it looks messy. So that's why you need to list the other 0, which we did. The other remaining 0 is 2 minus 3i. Do the same thing. 3, bring it down. 3 times 2 is 6. 3 times a negative 3i is a negative 9i. Now for these ones you won't need your calculator much because things will cancel. 9i and negative 9i are 0. 5 plus 6 is 11. Then we go 11 times 2 is 22. 11 times negative 3i is a negative 33i. Again, the i's will go away, so you don't have to worry about those. You get negative 26 into 22, we get a negative 4. Negative 4 times 2 is a negative 8. Negative 4 times negative 3 is a positive 12i. And since those are the opposites, we get our 0. So the second one should make it all nice. It's the first one you really need to use your calculator for. So we are here at the end. So the final part is 3x squared plus 11x minus 4. Let's factor that. We want to set that equal to 0. I'm just doing this off the top of my head. Let's see what we can do here. Since it's a 3x squared, we have an x and a 3x. We can do 2 and 2. If we do 2 and 2, that one works. We need to do a 4 and a 1. If we do a 4 and a 1, the 4 should be there, the 1 should be there, because that will give us a 12 and then a 1. It needs to be positive. So it looks like the factorization will be 3x minus 1 and x plus 4. Let me just double check that. Negative 1, positive 12. Yep, okay. So that means the other two remaining zeros are when these are equal to 0. We get x is equal to positive 1/3 and x equals negative 4. So the remaining zeros for the problem are 2 minus 3i, 1/3, and negative 4. Again, by using synthetic division to get it down to that quadratic, and then factoring or quadratic formula if necessary. Alright, and that's it. That's how you synthetically divide with a complex number.